Hello geometry students, I hope everybody's just doing very well. Today we're talking about symmetry and we're in section 9-5. What I'd like for you to be able to do by the end of these notes is to identify different types of symmetry and be able to relate them to real-world objects. So let's identify the two types of symmetry that we're going to have in this unit. There's line symmetry and there's rotational symmetry. And I'm just going to give you kind of a general definition of what these are. Line symmetry is when you can fold an image along a line and the image lines up perfectly. So line symmetry is something that you guys are used to seeing. Our bodies have line symmetry. Straight down the middle, our left side is the same as our right. Okay, next we have something called rotational symmetry. Rotational symmetry is when you can turn an item, or an image, I should say, by a certain degree and it will line up perfectly with the original image. So we're going to see that in action in this next example. So it says examples. Do the images have symmetry? If so, what kind? If it's a rotational, determine the angle of rotation. If it is line symmetry, then draw on the lines of symmetry. So let's just look at example 1. We're asking ourselves, is the left the same as the right, or are there any areas where I could fold along that triangle and find symmetry? Yes, there are some areas. So this one's going to definitely have line symmetry. So because it has line symmetry, I'm going to put those lines in. If I were to fold this triangle straight down the middle, and I folded it like left over right, that would have a line of symmetry. But not only that, I could fold this triangle through this point as well. So that would form a line of symmetry. But I could also fold this triangle through that point also. So this has 3 lines of symmetry. Now, I know that it does have line symmetry. So yes, it has line symmetry. But does it also have rotational? So for rotational, we're asking ourselves, could we turn this a certain degree and end up getting it to where the point is facing upward and the base is at the bottom? So if I were to turn this paper, notice how this is now in that same orientation. The point is at the top while the base is at the bottom. So yeah, I can turn this piece of paper and make that image look like it was in its original position, even though I've already spun it. So kind of a way to determine that degree of rotation is to look at how many points your shape has. So this has 3 points, and then I'm going to take 360 and divide it by that, because I know that 360 is a full circle. So how did I get like this point to this spot or something like that? Well, 360 divided by 3. So when I do that, I get 120 degrees. And after that, you're just going to count up by this number until you get up to 360. So I'm going to say 120 and 240 degrees. I don't want to say 360 because every single image in this world has rotational symmetry of 360. For example, looking at this triangle, if I'm spinning this paper and spin it some more, that's a turn of 180. Spin it a little bit more, That's a turn of 360 degrees. Of course, it's going to be back in its original image. So I'm just going to stop at 240. Okay, so, oh, I should put rotational. There we go. Now let's look at example 2. Does this have line symmetry? Yes, it does. It's going to have line symmetry straight down the middle. So I'm going to draw that line in. This does not have any rotational symmetry. So sometimes you do have line symmetry and sometimes you don't have rotational, or vice versa. Sometimes you have both, sometimes you have neither. So it's really all according to what your image is. So right here, I'm just going to say yes, and then it has line symmetry. Okay, for example 3, we have a trapezoid. Are we able to fold this in half anywhere to where it would match up perfectly on one side to the next? We do have line symmetry in this one as well. I can fold it straight down the center. So I'm going to say yes, line symmetry. Once again, if I were to turn this whole thing 360 degrees, yeah, this is going to be back in its original position, but that doesn't really count as rotational symmetry. If I were to turn this a 90-degree turn, this trapezoid is not in its same position. If I were to turn this a 180-degree turn, it looks as though it's upside down. So this does not have rotational symmetry. For number 4, I have this strange looking shape. Don't really know what it is, but we're going to determine, does it have line symmetry? Is there a spot that I could put a line that would make this, when I folded it, fall perfectly aligned with itself? No, there is no line symmetry in this, but there is rotational symmetry. Notice this kind of little leg is pointing to the left and this leg's pointing to the right. If I turn this paper 180 degrees, top leg's pointing to the left, bottom leg's pointed to the right. It still appears to be in the same orientation even after I've spun it 180 degrees. So I'm going to say, yes, this does have symmetry, but it's rotational at 180 degrees. Now in example 5, we have two different, I guess you could say, pictures. So up here, is there a way that I could spin this image to where it would look as though it were in the same orientation? Really, the only way I'd be able to do it is if I spun it 360 degrees. So we're not going to count that. Is there anywhere that I could fold this image in half to make it a fold right on top of each other? No. So this top image does not have symmetry that we can apply. However, if we look at that coffee cup and we put it at a different orientation, down here we do have symmetry. We have line symmetry straight down the middle of the mug and handle. So this bottom one does have symmetry, and it is line symmetry. All right, next we have the top of an umbrella that we're going to look at. This one can be kind of tricky, so let's just think about let's think about rotational symmetry first. Okay, so what I want you to notice is this paper in the current orientation, the bottom of the balloon or umbrella is flat, and the top of the umbrella is flat. If I were to only turn this a little bit, notice how at the top of the umbrella now is a corner. So I would need to turn that just a little bit more so that now, okay, top is flat and bottom is flat. Well, how many degrees did I turn that by? So I'm starting where top is flat and bottom is flat, and then I'm turning. All right, now I'm back to where top is flat and bottom is flat is again. And then I can do that once again like that. Top is flat, bottom is flat. So how many degrees is that turn? You can still figure out that rotational symmetry by kind of counting how many, I guess you could say, points are on the umbrella. So if I start here, 1, 2, 3, 4, 5, 6, 7, 8. So that 360-degree turn is getting divided up into 8 portions. So if 360 divided by 4 is 90, I can divide that by 2 again, getting me 45. So if I turn this, so first I'm going to say yes, rotational. If I turn this at 45 degrees, but then if I turn it another 45 degrees, that would be at 90. Or I could turn it another 45 to get me 135. Or another 45 getting me to 180. Another 45 would be 226. And then 225, my apologies. 270. And then 315 degrees. I'm not going to add that last 45 degrees because that would be 360, and we know that all shapes have 360 rotational symmetry. So yes, I can spin this umbrella to where it looks as though it's in the same position. But what about line symmetry? I'm going to have even more options for line symmetry, so I can cut through that umbrella like this. Or I could cut through it in half like this. But also this way. And then also that way. But I have even more line symmetry examples in this. What were to happen if I were to fold this piece of paper along this line right here? Well, this half would still line up with that half up there. So I can keep going, and now at every kind of point of this umbrella, there's going to be another line of symmetry. So this guy has a lot of lines of symmetry. And now we are done. So yes, it has rotational, and then yes, it has line symmetry as well. So as you can see, it's really just according to the example. Sometimes you'll have line symmetry, sometimes you'll have rotational, sometimes you'll have one or the other, and sometimes you'll have both, and sometimes you'll have neither. So it really is just unique to that specific example. We'll be doing the back of this page tomorrow for homework. So until then, please have a great night.